Well, hello, ladies and gentlemen of the 3C class. Welcome to Factoring Simple Trinomials. Our goal today, I know how to factor simple trinomials so that I can find the x-intercepts of quadratic functions. The other word for quadratic functions that we've been using is parabolas. So we're talking about factoring simple trinomials. This is not a new concept. We factored them last year, although we didn't really talk about them being the x-intercepts of a quadratic function. We saw that when we have a function in factored form, we can easily point out the x-intercepts. So for the one that I have on here, the x-intercepts will be -3 and +4. Now I'm just going to remind you how that works. X-intercepts happen when y is 0, and if y is 0, then each of these brackets have to be 0 in turn. So to make this bracket 0, I would have to put in -3, because -3 plus 3 is 0. And to make this bracket 0, I would have to put in a +4, because 4 minus 4 is 0. So our x-intercepts occur at -3 and 4. And if I were to graph this function, let's just do a rough sketch, it would cross the axis here and here, and remember it would have an axis of symmetry right in between those two. So this would be, oh, it's upside down. It shouldn't be upside down. This is not, there's no negative out front, so it's not upside down. And we go like this. Now this should be our vertex, even though I didn't get it sketched so much. The vertex has to be right in between the x-intercept, the two x-intercepts. So in this case, our two x-intercepts, if I were to find out where that vertex was, I'd go -3 plus 4 divided by 2, which would -3 plus 4 is +1 divided by 2. This is at 1/2. So this thing in here is at 0.5. That's the axis of symmetry. Okay, so if we have the x-intercepts, we can find out a lot about this graph, a whole lot more than something being in standard form, because standard form, while it looks nice and pretty, doesn't give us much information. So if we want the x-intercepts, we need to be able to put this equation into standard form. So we're going to, or not into standard form, into factored form. So we're going to take a look. First of all, we're going to look back at expanding very quickly and look for patterns to see if we can find a way of taking our answer that we're going to get down here and putting it back into the question form. So here we're going to, I've divided this into two categories, where the brackets that we're expanding have the same sign. Now remember, I'm starting with expanding because we're looking for patterns. So I'm going to expand this out, and remember, x times x gives us x squared, x times 5 gives us 5x, 2 times x gives us 2x, and 2 times 5 gives us 10. And to get our very final answer that will make this in standard form, we have to add those two things together. So x squared plus 7x plus 10. Now I'm just going to quickly do the rest of them like this. And we're going to try and take a look at some patterns. So these are the things we're going to take a look at and see if we can fill in the blanks about these two different things. So first of all, we want to remember that these are the two different categories, and that this statement, these statements follow this one. Brackets have the same signs. So if the brackets have the same signs, and that's the same signs, I'm going to highlight the word same. And over here I'm going to highlight the word different, because everything I put down here are for if they have the same signs, and everything down here are if they're different. So if the brackets have the same signs, we notice that the trinomial answer has a constant term that is always. So let's look up here. This is what I mean by the constant term. So here's our answer. What do we know about the constant? Oh, wait a minute. I made a mistake there. Whoop. Boop. Okay, that'll be a little bit better. Has a constant term that is always, and let's take a look at this one over here. If they have different signs, what's the constant term always? Well, in this case, the constant term is positive, and in this case, the constant term is negative. So if they have the same signs, the constant term is always positive, and over here, the constant term is always negative. Okay, now the next one says, so if the brackets have the same sign, we notice that the trinomial answer, now we're taking it, it says has a middle term that has the same sign as. So we're looking at the sign of the middle term. And over here it says has a middle term that has the same sign as. So now this one's kind of is a little bit harder to see, but we'll take a look at it anyway. So over here we've got a plus and a minus. So here's what it's the same as. This is a plus here. Well, that's what we had in the brackets. This is a negative here. Well, that's what we had as the brackets. So has a middle term that has the same sign as the expanded brackets. Over here, so if the brackets have different signs, we notice that in the trinomial answer, it has a middle term that has the same sign as, well, same sign as what? This one is negative, and this one is positive. So it can't be, well, and there's one of each here, so that's kind of good. But if we take a look over here, this is negative, and the bigger number is negative. And this is positive, and the bigger number is positive. So we're going to say has a middle term that has the same sign as the bigger constant term in the brackets. Can't fit. It's more words than I was anticipating. There we go. Okay, now the last one's, or the third one, there's still one more after this. I'm going to pull this down a little bit. Hopefully we can see what it has here. Okay, so it says has a constant term from blank the constants in the brackets. Well, this last term, if we ignore the sign, well, we don't even have to ignore the sign. It has the last term comes from multiplying 2 times 5 to get 10, and 2 times 5 to get 10, and same thing over here, so that's why they're all 10. So it has a constant term that comes from multiplying the constants in the brackets. Multiplying. Now this next one we're going to ignore the signs. This says has a middle term that comes from blanking the constants in the brackets. Has a middle term that comes from blanking the constants in the brackets. So what do we do here? We've got a 7 here. Ignore the sign this time. We dealt with the sign already up there. So we're just going to take a look at the number, like without the sign. That's called the absolute value, but we're going to take a look at that number. 7 and 7. What do we do to those two numbers? Well, did we add them? How about over here? 3 and 3. Our two numbers were 5 and 2. What happened there? We subtracted them. Okay. So has a middle term that comes from adding the constants and subtracting. Okay, there we have our patterns. These are all the patterns, and I'm actually pointing at it. You can't see that because my finger's not in the video. I'm going to switch this to dual screen. Hopefully you can still read it. And we're going to take a look and see if I can factor these using all of these this process. So it says let's use these patterns to write two brackets. Now remember, our ultimate goal is to turn these is to find the x-intercept of a quadratic function. So I've given you a quadratic function. We're not always going to be looking at quadratic functions, but I've started that way. That's why we have the y equals there as well. So the first thing that we notice is all the brackets have an X in front. So X and an X. And now what we're going to do, we need to figure out which category this falls into, same or different. So we're going to start with this first thing here. To figure that out is what's the sign of the constant term. So over here the constant term is negative. If the constant term is negative, we know that it falls into this category where they have different signs. So I'm going to put one bracket, one of each in there. Now I know they have to multiply to 36, and I know that according to this one here, that the bigger of the two numbers that multiply to 36 is going to have to go with the bigger constant term in the brackets. So I'm going to put the bigger number where the negative is. So the bigger number is going to have to go in there. Now I'm looking for two numbers that multiply to 36 according to tip number 3. And it says has a middle term that comes from subtracting the constants in the brackets. So these two things have to multiply to 36, and then let's actually read this backwards. This is just a little hint how to do this. They had to multiply to 36 and subtract to 9. So what multiplies to 36? Well, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't go, but 6 and 6. So we're looking for the pair of these, because these are all the possible combinations that multiply to 36. And we want to multiply to 36 and subtract to 9. Well, which one of those subtract to 9? I think it's this one, 3 and 12. Those subtract to 9. And remember, I have to put the 12 in the bracket that has this sign. So in here, 12 and 3. And so now, once we've done that, I know what my x-intercepts are. My x-intercepts are -3 and +12. So I'm going to quickly do that again here. Put down my two brackets. I know there's x's in the front. The first thing I have to look at is this last term, and this tells me what category it's in. So this tells me that it is in the same sign category, so they have the same signs. Then I have to look at this thing to figure out what signs they are. So here, when I figured out they had different signs, I could just put in a plus and a minus, and then I had to look at this sign to find out where the bigger number went. Here, now I find out what those signs are. They're both positive. If this sign were negative, they'd both be negative, because this says when the signs are the same, the middle term has the same sign as the expanded brackets. And we had up here two negatives, two positives, give me a positive in the middle, a negative in the middle. And now here's what we're doing. We're going to read this backwards. We're looking for two numbers that multiply to 24 and add to 10. They multiply to 24 and add to 10. So we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Those things multiply to 24. So which one are we looking for? We're looking for the ones that add to 10, 6 and 4. And all we have to do is plop them in. Okay, here we go again. Boom, 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 boom. Hopefully this doesn't take as much thinking, because it's 24 and we already did 24, so I already have those pairs. Now that I get those x's in, I look at the last thing that says it's negative. If it's negative, it falls into this category. They have different signs, 1 plus, 1 minus. So we're looking for two numbers that multiply to 24 and subtract to 5. Remember, we're going to read this backwards. Multiply to 24, subtract to 5. Well, let's look back over here, because I don't want to write these out again. These all multiply to 24. Which ones subtract to 5? If we have a look at it, there's the ones that subtract to 5. And remember, I need to know where to put the bigger number. Which one's positive, which one's negative. This tells me where to put the bigger number. So I'm going to put the 8 in here and the 3 in here. And this one, X at the front. We're looking for numbers that multiply to 12 and add to 7. Now, if this is positive, remember these two signs are exactly the same, and then this tells us what they are. They have to both be negative in this case. Okay, this tells us they're the same. When we look down here, positive means they have the same signs, and then they have to both be negative. So we're looking for the numbers that multiply to 12 and add to 7. So multiply to 12 and add to 7. So multiply to 12. Let's deal with that first. 1 and 12, 2 and 6, 3 and 4. Those are the only things that multiply to 12. And 3 and 4 are the ones that add to 7. So I'm going to put the 3 here and the 4 here. Okay, now I put the steps to factoring down. These are basically just the stuff that I've been saying to you. And I want you to pause the video for a moment and try to do this page. Have you paused it? If you haven't paused it, pause it and give them a try. And then come on back and I'll give you the answers. Okay, now I'm going to go through these very quickly. Hopefully you've had a chance and you've looked them over. If you didn't, do it now. Okay, but I've already written all of this stuff out so that we can do this as quickly as possible. So this one here, this tells me that the two brackets have the same sign and they must both be positive. So I'm going to put a plus and a plus in there. And that means when we read it backwards, I'm looking to multiply to 16 and add to 10. Well, there they are. These are all the things that multiply to 16. If you can't do this, if you can't figure out all the things that multiply to the last number, talk to me in class and I'll go through some strategies for finding those with you. But we're going to put 2 and 8 in there. Now over here, this tells me the signs are different, so I got to put one of each in. And then this tells me where I'm going to put the bigger of the two numbers I put in there. So we're going to multiply to 20 and subtract 2. There's an understood 1 there. Multiply to 20 and subtract to 1. There we go. 5 take away 4 subtracts to 1. And I have to put the bigger number in here that has the same sign as that. So 5 and 4. Next, down here. This tells me the signs are different, so I put one of each in. And this tells me that I'm going to put the bigger number there. Okay. So I'm looking for two numbers. We're going to read this backwards and multiply to 6 and subtract 2. There's an understood 1 there. Multiply to 6 and subtract to 1. Well, 3 and 2 subtract to 1, and I have to put the bigger number here. Over here, this tells me the signs are both the same, and this tells me they're negative. Now we're looking for numbers that multiply to 14 and subtract to 9. Or not subtract, add to 9. Multiply to 14 and add, that was an add sign, 7 and 2. Just plop them in. This one down here, this tells me the signs are both the same. This tells me they must be negative. So we put our two negative signs in here. They have to multiply to 7 and add to 8. Well, there's only one thing that multiplies to 7, so luckily it adds to 8. Now over here, this tells me the signs are the same. This tells me they're negative, so I got to put my two negatives in there. Then we have to look and say they have to multiply to 15 and add to 8. There they are. Multiply to 15, add to 8 is 3 and 5. We'll get some nice colorful stuff going on here. Last one. This one's a big one. So there's 6 different possibilities here. And this tells me the signs are different, so we got one of each. And this tells me where the bigger number goes. So I'm going to put the bigger number with the negative sign. So they multiply to 60, and subtract to 4. So which one of these subtract to 4? There they are, 6 and 10. And I have to put the bigger number in with the negative. Very last one. This tells me the signs are different, one of each. This tells me, or that sign there rather, this tells me that the bigger number is going to have to go here. And so they have to multiply to 15 and subtract to 2. Got them there. Bigger number 5 has to go there and a 3 there. And that wraps that up. And work on the handout page.